Hello, friends. So a lot of questions that I get from my students involve how to interpret these technical drawings, or what they mean, where do I start, just all that kind of stuff. So this video is going to be mostly about, well, all about, not mostly about, all about how to interpret these drawings, as well as kind of some tips and tricks on how to make sure that what you drew is correct. So all the drawings that I will be showing you today have these A and B values. I just chose a kind of random value. I tried to kind of match it to the drawing. So some students might receive an A value of like 127. Obviously that's going to make this way up here. So I just decided this is 10, this looks like 10, so we'll just make A 40. So I did that with all the drawings. So when you see the A and the B, just know that I chose an appropriate value for those variables. So let's get started. So this is drawing 6, and as you can see, it's this kind of weird slanted staircase that has a very large step in it. I wouldn't want to go up these stairs. But just to review a couple things, whenever you see the little crosshair with the long lines coming out of it, that's a center mark or center line. Usually if it's the crosshair, then it marks the center of a circle. You might see ones like this, where it's long line dash, so on. That's a center line. So center mark, center line. So this is telling you that it's symmetric, it's equal on both sides. From this view, it does not mean, because obviously if you look at it from the top, like over here is not the same as over here, but if you're looking at it from this side, it's symmetric. So where your center lines and center marks are placed within the drawing is also really important. Another thing to note, or to remind you of, is if you see just a line composed of a whole bunch of little dashes, that's a hidden line. So one thing I like to do if I'm struggling to read a drawing is to just draw a straight line up from views or across from views, because everything is going to be lined up. So you can just track this corner up to this corner. That was not a straight line at all, but so those corners match. So let's trace this center line up. That goes to here. So because we're looking at it from the front, if we were to look at, so the front view is looking at it this way, and this is looking at it from the right, and then this is obviously looking at it from the top. So if we're looking at it from the front view, we have no idea that there's this angle here. If this if this hidden line wasn't here, then we could assume just by looking at the front view that this goes straight back. These might be a little confusing to look at first, but it's showing you that the slant goes that way instead of that way, like this hidden line does. So it's similar to the hidden line, but you're able to actually see the slant from this side, from the front, because it goes in the other way. Let's see. So let's head over to SolidWorks, and I will show you a good way to check this drawing, and then we'll move on to the next one. So if we go to SolidWorks, here's drawing 6 that we have already constructed, that I have already constructed. So right away you can see that the isometric views match. So that's good. So then what you can do is use your view orientation, and we can go hit the front. And so we can see, oh, this matches. And we can kind of tell that these are slanted because they're a lighter color. You don't see the hidden line here because this is a solid shape. So another thing you can do is change the display style to this hidden lines visible. So it turns it basically exactly into what you're looking at in your drawing. So you have your square with the hidden line here, you have your rectangle, you have your other square. It looks exactly like the drawing does. So then we can move to the next view. So let's go to the front view. I'm sorry, the right side view. I know my views, I promise. So this looks exactly like the right side view of our drawing without the center mark, obviously. SolidWorks is not going to put those in for you. But you can tell that it's the same. And then just for fun, we'll look at the top view and we can see that we have the half circle and then all of our diagonal lines. So we can go back to our isometric view, which you can use during the view orientation or just hit Control-7 on your keyboard, and it does the same thing. So this is drawing 6. That's how you can check it. It's pretty easy. So let's go ahead and go look at the next drawing, which I've chosen as drawing 9. So for this one, we got a lot of angles here. So what I like to tell my students is draw wherever you can see the triangle that makes the angle. That's where I recommend starting. If that doesn't make sense, hopefully as I explain it, it will. So one thing to note again is whenever you have the dark black lines compared to just the gray lines, the dark black lines are going to be your dimension lines. So this is not a box, this is a triangle on top of a rectangle. We have that hidden line here again. That's showing you that something's happening back here. There's a cut somewhere, something, yeah. Sorry. So you can obviously see this triangle here, and that matches this right view. If you look at the isometric, you can see that triangle. So this is where I like to start with this one. I like to start where you can see the object best. Like here, you could draw this, but you're probably not gonna get what you want because you're looking straight at these angles, so these slants, and so it's not gonna look right. It's not gonna feel right. No. So then if we look at the top view, this is what tells us our inside diagonals here, angles. So then that's where I would make a cut from the top here, just straight down. What a lot of people think that when they're cutting these angles, they have to draw at an angle. It's not always the case. Sometimes that might happen, but it's not always the case. If you're able to look at a drawing and see a normal shape, like here's just a triangle, here's just a triangle with the tip cut off, then that's the view that you want to draw from. It's going to make your life a lot easier. Some people will try to make a plane to cut with. Some people, they'll just try a million different things, and they're not wrong, but they're just making it more complicated than it needs to be. But power to you if that's what you want to do. I'm kind of lazy, so I like to take the easy way. I like to try to make my parts in as few extrusions as possible. I like to challenge myself in that way. Because you could do this by drawing the bottom rectangle, extruding that, and then doing this part, cutting that slant away, doing this part, cutting that slant away, or doing it the other way, like make these, then cut it that way, and then cut it that way. You can do it in so many different ways. There's not a wrong answer. It's just some ways are going to be 50 times easier than others. So let's go back to SolidWorks and we'll look at our drawing 9. If you have a lot of drawings or open documents, you can hit Control Tab and it can show you all of your drawings or documents, parts, assemblies, whatever you're working on. So I went ahead and switched it to that hidden lines visible view. This is kind of cool to notice. It goes from a visible line to a hidden line. Of course, when I have my mouse on it, it's just orange. But I think that's kind of neat because it really shows you what's happening. Anyway, that's not the point of this. So we can see that our isometric view looks pretty similar. They're the same. So let's go to our front view. The front view is a little wonky to look at because you got the triangle, you got the weird, I don't know, just another polygon, weird shapes. But that looks right. So then we'll go to our right side view, have our triangle on top of our rectangle, and then we have the top view, and yep, we have our triangle with the tip cut off inside our rectangle. So perfect. So we'll Control 7 back to our isometric, and then we'll move on to our next drawing. I did do 6 drawings. I'm sorry if that's too many. I just tried to choose ones that had different things to offer. So now this one is a little more complicated than the other 2 we just looked at. So a couple notes here. This 2 times means that this radius 10 happens twice. So it's going to happen here and it's going to happen here. Sometimes you might have like an 8 times R10. And so usually to tell what those are is just if it doesn't have a dimension. Like this is not dimensioned with radius, so you can assume that that's the other part of this R10. And then we have this diameter symbol. So this circle, which we see half visible, half hidden, has a diameter of 20. And then we have that R20. So then this has a radius of 20. But this also tells us, so because this half circle goes from one side of the object to the other, then we actually know how wide this object is as well, at least down here. This B could contradict it. So if you did get a B value that was more than 40 or less than 40, then this part up here would be larger, but this bottom part is still going to be 40 across. And we know that it's 40 from here to here because we have this R20. Because from here to here is 20, from here to here is 20, so the whole thing is 40. So another thing to notice is this 10 TYP. So TYP means typical. So that's basically telling you that unless otherwise stated, this is all going to be 10. This is 10, this is 10, this is 10. It's all just 10. That's what your TYP means. So a handy little trick you can do is you can just draw the outside line here. Then you can use your offset entities tool. I'll point that out once we go back to SolidWorks, but we can use that offset entities tool, set that offset to 10, and then it will put in this line for us. So then we'll just have to connect the two, and boom, we're good to go. But for this one to kind of interpret it a little better, so this the front view tells you its basic shape. And then the top view is what tells you that you have these curves and fillets and circles and holes. And you can tell there's a hole from the front view as well because of these hidden lines. Usually if you see two hidden lines, it's going to be some form of hole, at least two hidden lines like this. So the main thing is just start where you feel the most comfortable. Start I don't know, sometimes where you feel most comfortable isn't always the easiest place to start, so you might get a little frustrated. However, my recommendation is to start where you can see the most basic part of the shape. So that in this case would be the front view. Because you have these weird curves and fillets, and that's kind of hard to do if you draw it from any other view. You could draw it from the top and then just cut this out later. It's ultimately up to you. You do whatever you feel is your style. So let's head to SolidWorks. We'll jump to drawing 18. And then first, that offset button, it's in your sketch tab, and then it's gray right now because I can't use it because I'm not currently in a sketch, but it's right up here. So here's this. Let's switch it over to that hidden lines visible. And so our isometric looks the same. Our front, that looks good. Sometimes when SolidWorks is doing this, it'll add in an extra little line where your curve starts. That doesn't mean it's wrong. Just know that that's where the curve starts, so that's good. You're fine. And we'll go to the right. That looks good. And then we'll go to the top. And that looks good. We have our half visible, half hidden circle. Yeah, we're doing pretty good if I say so myself. Let's move to our next drawing, which is drawing 21. Halfway done. I might try to speed up a little bit. Okay, so this one, the right and the top, it just looks like a whole bunch of lines. You have no idea what's going on. But if you look at the front, that's really where it tells you everything. So that's where I would start with this shape. Yeah, start where you can really see what's happening. If you wanted to, you could just draw this and then cut away all these little holes here. I feel like that takes longer. Actually, not necessarily, but just do whatever you're most comfortable with. In my opinion, there's two main ways to do anything in SolidWorks. There's an additive method and then a subtractive method. So the additive is just kind of adding things on top of each other. So you could do, this isn't a very good example of this, but if we go back to this one, an additive would be you do this part and then this part and then this part, and a more subtractive method would be to draw this whole thing and then cut away this part and then cut away this part. So it all just kind of depends on what you're most comfortable with. I prefer additive because I think it's easier to visualize, but that's just my opinion. That's how my brain works. Your brain doesn't necessarily work the same way that mine does. So we have this, ooh, what did I do? Oh, there it is. Okay, I'm not really sure what I did. I'm so sorry. We have this 2 times R10 again. So here's an R10, and you probably guessed it, here's another R10. And then another thing this drawing does is it gives us some clues. So usually the proper way to dimension things is you'll have an overall, and then you'll have all but one dimension. So we have this 20, we have this a minus 30, we have this a minus 40, we have this 10, but we don't have this. But from everything else, we can interpret that this is 10. We also don't even need to worry about this dimension. If we put all of these other ones in the SolidWorks, then it's gonna know what this is. If they were to include that 10 here, then they'd be over defining this shape. So if you think a dimension is missing, just keep going on without it, and chances are you'll have everything you need and you just don't realize it yet. I'm not actually, never mind. We're not gonna pop over to SolidWorks for this one just because we've been doing that a lot. So let's move to 31. So this one is a little more complicated. We got a lot happening. One thing that I've heard from students is sometimes they just look at this and get immediately overwhelmed. Don't you worry, just stay calm. You're doing great. You just start somewhere. Don't worry about that. This is another reason why I like the additive method. You can say, okay, I see 3 different parts to this shape. You have the bottom rectangle with the hole in it. You have this weird block with the slant in the hole in the middle. And then you have the I was gonna say angled, no, the curved part in the back. So that's 3 parts. You can do that. So start with your base. That's this bottom rectangle with the circle. And so we know that it's A deep and B wide, or long, excuse me. And then we know that this hole is in 15 from both directions and has a diameter of 10. That wasn't too hard. So we now have the base. And so to do this part, remember, at least I like to draw anything with an angle or a curve from the view that you can see the angle of the curve. With angles, that usually means looking for triangles. With curves, that means obviously looking for the curve. So for this block, I'm trying to find my triangle. It's over here. So here's my triangle. So you can actually click on this back face of the block you just made and draw this way, or sketch this way, excuse me. So you'll just draw a big rectangle with the triangle on it. So then you'll extrude that in, and then you'll have to cut out this part here. That's not too scary. It's not scary when you break it up into parts. It might still be a little scary, but it's not as scary. So that's my other recommendation, is just, if you get overwhelmed, take a step back and just try to break whatever you're making into different parts. If you can't really break it into different parts, like this one that we just looked at, then just focus on the most basic, what shows you the basic shape. And don't worry about this curve. You can cut it out or add a fillet to make this curve. Just draw this. The beauty of SolidWorks is you don't have to dimension as you go. You just draw the shape you see, and then you dimension it. Yeah, don't dimension as you go. It'll ultimately just slow you down. There's a few cases where you want to add dimensions as you go, but usually you're drawing maybe half of it and then dimensioning it, and then like for example, if you use the offset tool, you want to have this dimensioned and then offset it. Sorry, we're off track. That's really all I want to say about this one. Break it into parts. You got it. You're doing great. Once again, we're going to skip SolidWorks. Let's go to our final drawing. It's one of the more simpler ones, but it's drawing 46. Yeah, this one is pretty straightforward. You can see from the top view that you have this T shape, 3 rectangles. can see from the front that you have this L, and then there's a rectangle, but then there's some sort of cut somewhere behind this. Hidden lines really tell you that it's solid here, but behind it, there's a cutout of something. And then on your right side view, once again, we have T-shape, 2 squares, and a rectangle. This one you can do in many ways as well. You could start in the front view, you could draw the staircase, and then you could just cut this hole out afterwards. You could do a base rectangle and then add in these rectangles and then add in this one. You could draw just a giant rectangle and then cut all this away. You can do whatever you want, really. I'll show you SolidWorks, or this one in SolidWorks, just for one last hurrah. So our isometric's the same. Let's switch this to hidden lines visible. We'll go look at our front view. We have our staircase with our hidden line, or our L with our rectangle. So that's perfect. We'll go to our right side view and we have our T, 2 squares, and a rectangle. So that's perfect. Then we'll go to our top view and we have our T and 3 rectangles. So there we go. I hope that this helped you in some way to be able to interpret these technical drawings more. Really just the main advice I have is just take a step back, try to break it up. If you really get stuck, then reach out to someone for help. I'm always available, but I know you can do it. Just believe in yourself. Try not to get frustrated, because if you get frustrated, you're really going to struggle even more. Go back to your fundamentals. Just look at if you have center lines, if you have hidden lines. Sometimes it's much harder to look at your 3 views. So you might want to look at your isometric and try to match up, like, okay, so here is here, and here is here, and then this hidden line must be this cutout. Just try different things and see what works for you. One last thing, sorry, this is kind of long, but one last thing. So you have height, depth, and width, right? So each view is going to have 2 of those. So your front view is going to have height and width. Your top view is going to have width and depth. And then your right side view is going to have depth and height. So that's not super important, but sometimes it helps you to narrow down where you need to look for an overall dimension. Overalls are important because they tell you really how long your object is. So if you can't find the width here, then you know it's probably on the top view. If you can't find the depth here, you know it's probably on the right side view, because you can't show depth from this way. You just can't. That's all I got for you. If you have any questions, let me know, leave a comment. Yeah, this has been how to interpret technical drawings. I hope you enjoyed and found it useful.